Hi, thank you everyone for being here. I'm super excited and honored to introduce our first guest, first speaker, but to keep the introduction short, he is a world-renowned Scientia professor of artificial intelligence at the University of New South Wales, Australia, and he's written extensively on the future potential of artificial intelligence. Please give a warm welcome to Professor Toby Walsh.
Thank you. Great. Well, it's a really exciting time to be, as you heard in the introduction, a professor of artificial intelligence. You can't open a newspaper today without finding multiple stories about artificial intelligence. A couple of days ago, there was news broke about AlphaZero, where DeepMind, the part of Google that's been making some news, showed that they could learn how to play chess, Go, and the Japanese version of chess, shogi, from nothing in a few days and eclipse thousands of years of human knowledge about the game and play at superhuman level. Another example from earlier this year, this is a friend of mine, Thomas Sandholm, who's a professor at CMU. I've got a long-running bet with him to see which of us is the worst squash player on the planet. Fortunately, I haven't got a long-running bet with him to see who's the best poker player because he's written a program, Liberatus, that in some sense is actually even more impressive than the DeepMind AlphaZero because it plays poker better than any human now. And in poker, you've got to deal with human psychology, you've got to deal with the fact that you can't see all the information, the uncertainty about how the cards are going to unfold. So much more like the real world than a rather artificial board game like Go or chess. But these are lots of examples. You can't, as I said, you can't not open the newspaper and find more examples of how AI is starting to infiltrate our lives. So I just want to begin, before I start talking about ethics and the future of AI, just say, well, why is it now? I mean, I spent my whole life dreaming about building machines that could think, but why is it now that we seem to be making progress? And it's not because of any real step change, any quantum change that's happened in AI. It's the convergence of 4 exponentials. Now, you hear a lot of mumbo-jumbo about exponentials and about how we live in exponential times. And a lot of it is mumbo-jumbo because all exponentials eventually run out. But these exponentials, while they've been progressing, have been really useful. The first exponential, one that probably the whole room already knows about, even has a name. That's Moore's law. Now, here's a graph of Moore's law. It's the doubling of transistor count, roughly a doubling in computer power that we have every 18 months or 2 years. Now, the graph may look a little unfamiliar because when normally you see a graph of Moore's law, it's plotted on a logarithmic scale, 1, 10, 100, 1,000. Here I've plotted it with a straightforward linear scale, and you can see how the graph really takes off at the end. And the fact that we now have in our smartphones more compute power than took us to the moon and back. And that's made a real difference. Things that we thought about 20 years ago, we can now do because we just have enough processing power. If we don't have it on the device, we have it up in the cloud. So that's the first exponential. The second exponential, again, it's a doubling every 2 years. I mean, interesting thing is all these exponentials, they're all empirical, observational laws. There's no necessity that they are every 2 years. They just happen to be that way. And just as before we leave Moore's law, by the way, little known fact, Moore's law is now dead. In fact, has been so for 3 years. Intel and all the other chip companies are not trying to meet Moore's law anymore. The only reason it happened after a while, after Gordon Moore, the co-founder of Intel, observed the fact that we had been doubling transistor count all the way back since we had vacuum tubes. That became the corporate plan of Intel and all the other chip companies to actually build the next fab plant that could actually shrink chips even further. Well, we're running into quantum limits, and so they're not going for a doubling in chip count. And so, since they're not going for it, no one's going to be building the fab plants. It's not going to happen. Interesting aside, Intel are going for better power consumption so that we can have more power, more compute power on our devices. But anyway, this exponential, officially now dead, but nevertheless been very useful up to now to give us a doubling in compute power. There's a similar doubling in data. And we've had, it's doubling every 2 years or so. With the Internet of Things, that's only going to continue. This exponential war, I'm sure, can carry on for a bit longer than Moore's law. And a lot of what we're doing in AI these days is machine learning. That needs a lot of examples. AlphaZero played more games of Go than any human could ever play in its lifetime. So it needs lots of data to learn from. But we're getting that data. Our devices are collecting all that data. Our corporations are collecting the new gold. Of course, the new oil is data. Corporations are realizing that the most valuable thing they have is the data. And so we're having more and more of that data to learn from. The third exponential is what we have been working in AI for 50 years, and we are actually improving the algorithms. Deep learning, still 25, interesting fact is backpropagation, the heart of deep learning is 25-year-old algorithm. There's been some tweaks to it. Those tweaks have been very effective, and you can see the doubling in the error rate. So back in 2011, this is a standard AI benchmark image recognition. See a picture, can you name an object in that picture? There's a car, there's a pedestrian, very useful if you're building an autonomous car, right? Back in 2011, 1 in 4 images were incorrectly labeled. Absolutely useless. You can't drive a car if 1 in 4 of the things you're seeing is not the thing that you think it is. And that's doubled to 1 in 10 in 2 years, and now over about roughly 1 in 20. Interesting, there's a very little thin green line you can see at the top of that graph. That's human-level performance in this benchmark. So now we can recognize images better than humans can, which is why we're going to have autonomous cars, amongst other things, very soon. And the fourth exponential, I promised you 4 exponentials. The fourth exponential, this is not a technological one, this is a financial one. The amount of money going into the field. Here it's measured by the number of dollars in VC funding, or just the straight number of deals going on. And that's been roughly doubling again every 2 years. Again, that's not going to go on forever. But nevertheless, you put those 4 things in a pot together. You put more money, so more people working on the problems. You put better algorithms. You put more compute power and more data that can run on that run with that compute power. You have a recipe for what we're seeing today, which is AI is starting to make lots and lots of more decisions in our lives. Now, one thing I always have to reassure an audience like this is that the machines are not taking over anytime soon. We don't have to worry about Skynet or Terminator. Machines have no consciousness, no sentience, no desires of their own. They do what we program them to. We'll come to the consequences of that in a second. But you do not have to worry. Ignore what Elon Musk is tweeting about AI, please. He's a great engineer. He builds fantastic cars. I'm sure he's going to get mankind to Mars. But his concerns about AI are a little overblown. We struggle to make, at the moment we make idiot savants, machines that can do one task, play Go, answer Jeopardy questions, read mammograms, do one task very well. But they don't do anything else than that one task. And one other thing that you need to not worry about, you read almost every day again that AI is going to displace all our jobs. Now we have no idea. You read lots of reports that say how many jobs. The most famous one is a report that goes back to 2013 from the University of Oxford, from Frey and Osborne, that made this wonderful prediction. 47% of jobs in the United States are at risk of being automated in the next 2 decades. No one has any idea how many jobs are going to be automated in the next 2 decades. All technologies have created new jobs, and they've destroyed other jobs. We have no idea what the balance is going to be this time. Anyone who gives you a prediction, especially to the accuracy of 47%, is deceiving yourself, if not themselves. We have no idea what's it going to be. It is going to be a period of disruption, but just to understand this issue better, I'm a scientist. I went and looked at their data, right? So I looked at the data that they used, their prediction. Ironically enough, actually, they predicted the number of jobs that are going to be automated with a machine learning program. So the job of predicting who's going to be automated has now been automated. Not many people saw the irony of that. But anyway, I went and looked at the data from which that prediction was made, right? So if you put rubbish in the data, it's garbage in, garbage out. So one of the predictions, right? 98% chance that bicycle repair person is going to be automated in the next 2 decades. I can guarantee you. I will put lots of money on this. There is 0% chance that bicycle repair person is going to be automated. It's not 98% chance, 0% chance. For one thing, if anyone who's tried mending a bike knows it's a fiddly, difficult thing, it's going to be immensely hard to build a robot that can do that task. It's going to be an expensive, really expensive robot. It's not something that we're going to do in the next 2 decades. Secondly, this is not a technological one, this is again an economic argument. A bicycle repair person, unfortunately, is not a very well-paid job. We're not going to put a really expensive robot in the place of a really cheap job. And the third thing, it's a sociological thing. A friend of mine owns a bicycle shop. I said to him, well, what about this prediction? He just laughed. He said, we lose money repairing bikes. I said, well, why do you repair bikes then? He said, to get people in the shop, to talk to them, to sell them more kit. And so again, that's not a job that you're going to give to a robot. That's a job for a person. It's about relationships, about our emotional and social intelligence. Again, something machines have none of at the moment. So there's one example. Just one other example, just to show you how doubtful this 47% number is. Another of the predictions, 98% again, chance of being automated in the next 2 decades. Model. I mean, I don't know about you, but I'm not interested in how robots look in clothes. And with all respect to every woman in the audience, we are not going to build a robot that knows how to walk in high heels anytime soon. So there's no chance that model is going to be automated in the next 2 decades. No chance at all. So you have to treat these sorts of predictions with a lot of skepticism. But one thing is absolutely certain. There will be jobs that will be taken. Driver is one of them for sure. We're going to have autonomous cars, autonomous trucks. So anyone who earns their living driving, it's going to be far cheaper and far safer to have machines drive you. So those jobs are going to disappear. And new jobs, like with every technology, new jobs will be created. That happened in the Industrial Revolution. Most of us used to work out in the fields. New jobs were created in offices and factories that didn't exist. So new jobs were created. But one thing is absolutely certain. We know for sure, we don't know whether more jobs will be created than destroyed. But one thing we do know for sure, and that's why this room is a really important room to be having this conversation with, is that they'll require different skills than the old jobs. Absolutely certain for that. And therefore, and these will be technologies that are yet to be invented as well, therefore, education is going to have to become completely lifelong. It's not something that you can leave school with the skills that will last you the next 50 years of employment. It's not something you can leave university with. We're all going to be working with technologies in 20 years' time that were invented in 10 years' time. And so we need to work out how to transform our society so that education is going to be a lifelong thing that we can do while we're on the job, even if that's part of the gig economy. One aspect of education that I think we really have to start thinking about and start focusing on is about ethics and philosophy. So here's a question for the audience. When was the golden age of philosophy? Now, who thinks it was, Plato, Aristotle, and, all those bearded Greeks, those hipster Greeks? Yes? Maybe you're the school of all those continentals like, Descartes and Leibniz, who helped, get us out of the Dark Ages. Or maybe you're of the school that, was it the time of Bertrand Russell, who was, famously thought to be the most intelligent man alive when he was a philosopher, or Gödel and Frege and all those wonderful logicians at the turn of the century. Well, this is a trick question. The golden age of philosophy is the next 50 years, because we're going to give machines the right to make decisions. And machines are painful, as anyone who's only done any programming, machines are painfully literal in what they do. And so we're going to have to be very explicit about what those decisions are and what the criteria, what the ethical choices those machines are making. Things that we never had to make. So we hear this all the time. We hear people often talking about things like the trolley problem, about how cars are going to be driving, autonomous cars are going to be driving along, and then they're going to face a life or death decision. They're going to have to decide whether they drive into the pedestrian who's just stepped into the road, or they drive into the brick wall, possibly killing the passenger of the car. Now, these aren't new problems. These aren't new ethical problems. We've faced for 100 years trolley problem. Every time you've ever got in a car, at any moment in time, you might have had to solve a trolley problem. But we've never had to solve trolley problems up front and write down explicit instructions, explicit enough that the computer could do them, that tell you what the answer to this challenging moral dilemma is. And that's just an example. I want to just spend a few minutes going through a couple more examples of how these difficult ethical choices are going to be entering our lives, and ones that we as a society, we need to start thinking about and actually coming up with some better answers with. And this is why it's going to be the golden age of philosophy, because philosophy's got sidetracked by, are there any philosophers in the audience? I hope not. Oh, well, philosophy's got sidetracked by thinking about language and all these irrelevant things, and now is actually going to have to do something really practical. It's going to have to tell us how we write code, how we write programs to solve these things that we as humans have implicitly solved ourselves. As I said, anytime you've ever got in a car, you may have had to solve a trolley problem, but we didn't have to code that up front. And if you had that situation, hope it doesn't happen to you. But if that happened to you, if you survived the accident, you did the wrong thing, well, you could face manslaughter charges. But that was post hoc. It wasn't something that we had to think up. What are our priorities as a society up front? So here's a really fantastic example that happened. The story that broke a year or two back. This is an example of using machine learning to predict who's going to reoffend. Now, you could. So you've got a lot of historical data, you could make a prediction, you could do much better than humans at predicting who can reoffend. Now you could take such a program, this program is actually in use today in 20 of the 52 United States. You could take such a program and you could use it to decide, well, where do we spend our limited probationary services? Where do we focus our attention to help those people most likely to reoffend, make society a safer place? And I think most people in the room would say, yeah, that sounds like a good thing to do. That sounds like a useful bit of technology that can, we can spend our money more wisely. We can make society a better place. We can help the most needy people. That's not how this program is being used. It's being used by judges to help them decide sentencing and parole and bail conditions. You're probably thinking, I'm not so sure we should be handing over such a delicate decision to a machine, depriving someone of their liberty. One of the most challenging things, one of the most severe decisions we make as a society. Now, there's an absolute kicker to this story, which is it was shown that this program is racially biased. It's more likely to predict that black people will reoffend than they actually will, and it's more likely to predict that white people will not reoffend than they actually will. So the bottom line is that people are being kept locked up by a buggy program, and that people are perhaps being dangerously released in society because of a buggy program. Now, why is that? I'm sure the people who wrote the program didn't intend it to be racially biased. Race is not one of the inputs to the program. But postcode is. And postcode is a pretty good proxy for race. There are neighborhoods that are largely one race and neighborhoods that are largely another race. And so, not surprisingly, it learned from the historical data. And dare I suggest that there are lots of cultural and other racial biases in the past, that maybe police officers were more likely to arrest black people. Maybe judges were more likely to put black people into jail. And so we're learning from that historical data. And if we're not careful, we will bake into the program the historical racial bias that most of us would like to get out of our society. And so we're discovering how difficult it is, even if you hand over these decision machines, to make sure that they're not racially biased. And then, what does it mean not to be racially biased? Because at the end of the day, maybe we're just locking people up because they're poor. And we will continue to lock up people because they're poor unless we work out how to deal with that. Well, what do we mean by the program making a fair decision? Another very good example, this one's good because it shows how the tech companies need to wake up to their responsibility. This is Google Photos. It was discovered about a year ago that Google Photos was unfortunately labeling. So this was remember the image recognition problem that we were talking about that's been doubling in performance. This is an example of that algorithm being used. You load your photos into Google Photos, and it can identify objects in there. And it made a very unfortunate classification here. It labeled some black people as gorillas. Deeply offensive. Now, it was, a few years back, the case that image recognition programs were very bad were racist in its essence, very bad at identifying, for example, black faces, because the training sets weren't very balanced. It's not clear that the training sets are not very balanced. Actually, I think what this example shows more than anything is that AI programs break in brittle ways, break in ways that humans don't break. And they have no common sense and no idea of offense. No idea. It labeled white people as seals. Most white people can live with that. But black people, for cultural reasons, we know how deeply offensive it is to label black people as gorillas. And the program has no understanding of what it's doing, and therefore no understanding of the offense of this misclassification. And I want to end with a final example and then leave time for a question or two. Facebook, just an example. The tech companies have been experimenting on us. Now, it used to be that they were experimenting to decide what color blue to put in the blue logo of Google, right? Nothing very important. But it was discovered that Facebook was actually just working out whether by changing your newsfeed, you could make people happier or sadder. Now, if I want to run an experiment on you, the public, I have to go through ethics approval, I have to get your informed consent, I have to go in front of an ethics panel. It's a big deal. It's a huge amount of work. Facebook does none of that and did none of that. Despite the fact, actually, they had some academic partners. They did none of that. They got no consent. When you click the button to log in, to sign up for Google, you gave them consent to do anything they like on you. If I told you that there were drug companies that were testing their product, but knowing that it would harm people, you'd say, no, that's not allowed, and it's not allowed. But somehow, we give tech companies a free ride to experiment on people. And maybe those people got so sad, they went and committed some self-harm. We have no idea. There was no safety put into the system at all. We give the tech companies far too easy a ride. And the final one, there was this experiment to decide if you could recognize whether people were heterosexual or homosexual. Why would you do this, even if you could? Terribly flawed study. But I'm going to finish there just by saying, there are many positives. The machines can take the sweat if we make the right choices, if we worry about the ethics of what we're doing, if we're informed as a population. That's where you come in. It's going to be increasingly important that we, the consumer, we, the public, are better informed as to what we should be demanding from people like the tech companies. We do have the potential to improve the productivity of our economies, to improve our healthcare, to personalize our medicine, to make us all healthier, wealthier, and happier. If you want to read more, I can encourage you to read my book, which is just out. Thank you very much. I think we have 3 minutes for questions as well.